All right. It looks like it's 9 o'clock. So with your indulgence, Board of Trustees of the UP College of Engineering and the UP Engineering R&D Foundation, I'm Dante Briones. I'm the Vice President of the Foundation. Will be your host today. First of all, we'd like to greet all of our alumni and friends in the Philippines. As you have seen in the chat room, we have people from all over the country. We have friends from the US, and I'm sure there are people out there from the rest of the world. Thank you for joining us today. This is the second part of a three-part series on high-performance computing. In the first session, we listened to three distinguished scientists discuss sample applications of high-performance computing and its benefits. We also honored our early donors to fund our project on high-performance computing at the College of Engineering and those supporting our professorial chairs in the various projects of the foundation. For today, we have another set of prominent scientists from the College of Engineering and from the Advanced Science and Technology Institute of the Department of Science and Technology. We will also take time to honor several new round of donors of the HPC project and the other projects of the foundation. To start with, I am honored to introduce to you Professor Ferdinand Manigdec, the Dean of the College of Engineering and an ex officio trustee of the UP Engineering Research and Development Foundation. He is a professor of mechanical engineering, earned his ME degree from UP in 1979 and Master of Science from the University of Leeds in the UK. Let us all listen to the message of Dean Manigdec.
To the UP Engineering Research and Development Foundation officials led by President Ferdinand de la Cruz, Chairman Alex C., Executive Director Alfonso Aliga, Board Members Dante Briones, Edgardo Atanasio, and Chicho Mantaring, to our dear high-performance computing and professorial chair donors, College of Engineering officials and faculty members, engineering alumni, and fellow Zoom webinar participants from here and abroad, good morning and good evening to those who are joining us from the US. I wish to welcome you all to the High Impact Research and Development through High Performance Computing Zoom Webinar Series Episode 2, Upgrading Research Quality and Productivity. Almost 2 months ago, or last August 14, the first of a series of Zoom webinars on high-impact research and development through high-performance computing was conducted. This virtual event also launched the 20 million peso fundraising drive spearheaded by UP Engineering Research and Development Foundation in partnership with the college and the UP Alumni Engineers to set up a state-of-the-art high-performance computing laboratory at the UP College of Engineering. I am happy and overwhelmed by the support of our alumni friends here and abroad who share the same vision as the college of being a global leader in engineering education, research, technology innovation, and service by helping in equipping the college with this very high computing facility by 2021. The high-performance computing facility will take only an hour for complex simulations and numerical computations. This implies a tremendous increase in research productivity and improvement in research quality. The college can then address various valuable computing requirements of other colleges, universities, and industry. Faculty members will be able to access research laboratories abroad. I would like to thank our high-performance computing donors, Mr. Jose Albano, Mr. Helbert D., Mr. Daniel Reyes, Mr. Agosto Lagman, Mr. Manuel Frondoso, Mr. Dennis Carpio, Dr. Salvador Reyes, and the Friends of UP Foundation in America with its treasurer, Ms. Polly Cortez, and many more. Similarly, we are also indebted to our new professorial chair donors, Mr. Elsar Simon, Dr. Aura Matias, Mr. Ronaldo Ison, and the Philippine Society for Soil Mechanics and Geotechnical Engineering President, Dr. Alexis Acacio, mostly responsible for convincing our donors to support this endeavor by showcasing the relevant research works that entail high-performance computing are Professor Emeritus Guillermo Tabios, Associate Professor Per Errol Kinay of the Institute of Civil Engineering, and Professor Gerard Denoga of the Department of Mechanical Engineering. In a little while, we will be hearing the presentations of our equally brilliant faculty researchers that will highlight different applications that necessitate massive computing. They are Dr. Ariel Blanco of the Department of Geodetic Engineering, whose presentation is about high-performance computing for geospatial information and decisions. Dr. Vena Bongolan of the Department of Computer Science, who will talk about high-performance computing application at the Department of Computer Science, and Mr. Peter Antonio Banson of the Department of Science and Technology, who will be speaking about the high-performance computing initiatives at the Department of Science and Technology. Once again, thank you to our donors, the UP Engineering Research and Development Foundation, who also organized this webinar, and to all who joined us this morning. I hope you would all have a pleasant day. Mabuhay.
I'm sorry. I was so excited I forgot to unmute myself, but I was introducing our first speaker, Dr. Dinoga. He has a PhD, Doctor of Philosophy in Energy Engineering from the University of the Philippines. He also has a master's degree in Mechatronics Engineering from University of New South Wales in Australia, and his Bachelor of Science in Mechanical Engineering from UP graduated cum laude. Dr. Dinoga will tell us how we intend to build, operate, and run the HPC facility that we are talking about in this webinar. Dr. Dinoga, the floor is yours.
Thank you, Dante. Hello and good morning to those joining us from the Philippines, and good evening to those joining us from the US. Welcome to the second episode of our webinar series on high-performance research through high-performance computing. Today, we tackle upgrading research, quality, and productivity through the establishment of an HPC facility and the UP COE commitment. Here at the UP College of Engineering, we strive to develop engineering solutions to address the pressing problems of the country. Our research include the designing of earthquake-proof buildings, predicting storm surges, developing safer vehicles, and discovering new medicine. Such research are not always successful because they require a lot of computing power. However, more than ever, there is a bigger demand for such research. Hence, the college recently decided that it is high time that we should establish our own high-performance computing facility, similar to what other universities and research institutes around the world already have. Such a facility will allow us to significantly upgrade our research quality and productivity. Instead of a multi-million-dollar supercomputer, the high-performance computing facility that we aim to establish is in the form of a computing cluster. An HPC computing cluster is comprised of dozens of computing nodes that are actually similar in power to a modern desktop. These nodes are interconnected via a very fast network. A scheduler node receives a complex computing job from a remote user and distributes portions of that job to the individual nodes. With the help of specialized software and the fast network, the nodes work in parallel to complete the entire job. By combining the power of dozens of nodes, the proposed engineering HPC cluster would be about 5 times faster than the Blue Gene supercomputer. Unlike a supercomputer though, because of its modular configuration, we can actually upgrade individual nodes to minimize obsolescence and even increase the total computing power. This immense computing power of the cluster is actually even accessible remotely via the internet. This is a huge advantage in today's pandemic, allowing us to do our research remotely. The scheduler node can also allocate computing power per job, allowing hundreds of users to run their programs simultaneously. This is the initial capacity of the HPC cluster that we intend to install. We have about 36 computing nodes with 70 individual processors and over 1,000 CPU cores, over 3 terabytes of RAM, 16 terabytes of SSD storage with a total of 76 terabytes. Now this configuration has such immense computing power that you can actually run a simulation that would normally take months to run on a normal desktop. It would only take days to run on this particular cluster. A computing cluster would be useless without software to run on. This slide shows some of the software that we plan to install onto the cluster. For example, MATLAB is a numerical computing environment and programming language that is ubiquitous in the engineering field. We recently acquired the full suite of MATLAB and Simulink products for an unlimited number of users. UP Diliman had committed to annually fund this for 3.4 million pesos a year. We also currently have a perpetual license of the multi-physics package of ATSYS. This is a finite element analysis software of which we plan to upgrade to maximize usage on the HPC. We also currently have a subscription of the Schrödinger software used for chemical simulation, pharmaceutical, biotechnology, and materials research. This was funded by the UP Engineering Research and Development Foundation Incorporated. We also plan to install open source software like Delft3D for hydrodynamic and coastal engineering simulations. In addition to the support already mentioned in terms of software acquisition, I would like to share our view of how this HPC facility can become sustainable. Currently, the college already has allocations for operational expenses like electricity. The university also provides us funds for our graduate school, of which we expect to be the heavy users of the HPC. A recent survey actually showed that over 2/3 of our students were considering computational-based research over physical laboratory research. The most significant source of funds would be from our research projects. The college, through our departments and faculty, receives over 500 million pesos of research grant money each year. Many of those projects will directly fund the acquisition and maintenance of the niche software needs of the project. A portion of the indirect cost of those projects are earmarked for the HPC. Such funds will be used for the modular hardware upgrades previously mentioned. Our objective is to make sure that we can upgrade at least 20% of the nodes each year. The funds will also be used to hire full-time systems administrators. Experience has taught us that equipment like this requires skilled people to watch over them, as well as assist the researchers in using the facilities. The heart of the cycle of the sustainability is the presence of the HPC facility. It is an enabling facility that upgrades our research quality and productivity. Just like in the movie Field of Dreams, if you build it, they will come. Help us build an HPC in the UP College of Engineering. Thank you and have a good day.
Thank you, Dr. Dinoga. It looks like this facility will increase our capability for R&D more than tenfold. So at this point, I'd like to call on Engineer Victor Villagracia. Vic is a mechanical engineering graduate of UP in 1975. He is currently the Senior Vice President at UBS Wealth Management and based in San Francisco. Vic and his wife Carol sponsored the professorial chair and thesis support grants for the college. He is active in U.S. fundraising as a member of the UP Engineering R&D Foundation and Friends of UP Foundation in the USA. Vic will give us an update and introduce our new set of donors. Vic, please go ahead.
Thank you very much, Dante. Good evening to our U.S. friends and donors, and good morning to our Philippine friends and donors. I hope you're all keeping safe and healthy. I'm very fortunate that my part of the program is a very happy one, whereupon I get to show appreciation and I get to thank our recent donors by recognizing them today. In the interest of time, though, I will recognize each of the donors and give a brief bio of the person or the organization. That way, we can give more time for the donors to say something about themselves and why they want to help UP with their donation. But before that, let me give you an update on the fundraising since our first webinar in August. Out of the 20 million peso budget proposal, we have raised a total of approximately 9.5 million pesos. We expect to raise the next 10.5 million pesos in time to have the computer solving problems in the second quarter of next year. Now to go to the most important part. We are delighted to recognize the following donors for their recent pledges. You know, the majority of our donors are repeat offenders, meaning they have made donations in the past to UP. First off the list is the Friends of UP Foundation in America, or PUPA, which is a nonprofit U.S. institution established in 1982. The goal of this 501c3 foundation is to facilitate contact, information dissemination, discussion, and gift giving between and among the UP-based, US-based alumni groups and individual alumni friends and the University of the Philippines. PUPA, at their last board meeting, approved a matching grant of $125,000 to the high-performance computer for the UP College of Engineering. Thank you very much, PUPA. Ms. Polly Santiago Cortez, the vice chair for 15 years, now in transition to CFO, will speak for PUPA later on. But at the same time, too, I'd like to honor and recognize Polly Cortez. Polly is a donor as well to the HPC. Polly is a BSBA accounting major graduate of UP and an MBA from Golden Gate University in San Francisco. She retired as a federal banking regulator at the U.S. Department of Treasury after 38 years. She now volunteers in many charitable organizations that helps the Philippine community. Polly lives in Concord, California. Mr. Dennis Carpio, a CHE graduate, is now retired after a long productive career in international finance. With his wife, Martha, they were the largest donor to the UP Engineering COVID Fund drive and have generously contributed to the HPC project. They live in Virginia, USA. Our executive director, Tito, will say something about Dennis later on. Mr. Al David, the recent donor, Al left UP for the US before completing his engineering. He received several engineering technology diploma at the Community College of San Francisco, spent 4 years at Cal State East Bay as business major, and 2 years at UC Berkeley to earn his certificate as purchasing manager. He retired after many years from the utility company Pacific Gas and Electric. In the Philippines, our recent donors are Mr. Manuel or Lito Frondoso, a chemical engineer, is the president and CEO of Sugeco Inc. and a director at Sea Oil Philippines. Lito, as he is called, is a former chairman and currently sits in the Council of Advisors of the UP Engineering Research and Development Foundation. And the last one is Dr. Salvador Noni Reyes. Dr. Reyes is a professor of civil engineering at the UP College of Engineering. He is a revered professor and a looked upon advisor and consultant in geotechnical and structural engineering. Doc Noni is a longtime member of UP ERDFA. Now let's hear a few words of wisdom from our donors so we may learn the virtues of giving back to our alma mater. Polly, would you like to start with that? Hi, Polly. Yes.
Hi. Greetings to all alumni to UP ERDFA. Thank you, Vic. I'm here representing the Friends of UP, Friends of UP. That's been around since 1982, and it's always been chaired by a UP president. That has never changed. The vice chair only serves as an executive director in charge of the operational aspects of the foundation. We have been a philanthropic partner for all alumni in North America, as well as non-alumni, because I'm mentioning non-alumni because that's how it was envisioned in the beginning, that Friends of UP will attract not only alumni but also friends of alumni, because we got a professional professorial chair from a non-alumni in 2016. That's out of the blue, try to research and find out how they can honor a faculty and vice president of the UP administration in 2016 with a professorial chair. So it works that our name is called Friends of UP because we can attract non-alumni as well as those who are generous alumni of UP. Friends of UP is a very unique foundation because we don't conduct our own fundraising events. Rather, we collaborate and facilitate all the groups trying to help UP in every way they can, either professorial chairs, different programs, different campaigns for small projects or facility improvements. Because as a 501c3, we can acknowledge their donations, and they can use that acknowledgement of donations for the IRS purposes for tax deduction. Of course, we always give them the qualification that to the extent allowable by law and with the clearance from their financial advisors. We feel at Friends of UP that to be a world-class educational institution, Friends of UP should consider this matching grant of $125,000 for this high-performance computing system. It's very rare. In fact, this may be the first time that we took exception to our internal rules and guidelines to how, in terms of the annual amounts that we can give to UP, because we feel that this project will boost UP to the next level, to the world-class educational institution, as well as help the Philippines altogether. So it's a worthwhile project as we feel it. And so we challenge all the alumni, especially the engineering graduates, to rally and get on the bandwagon to match this pledge of Friends of UP of $125,000. Personally, I also made a small donation because I believe in the project, and I think it will boost the qualifications of the Philippines and also the ranking of UP worldwide among educational institutions if we have a high performing computing system. So that's it. Thank you.
Well, thank you very much, Polly. That's a very nice talk and very nice inspiring chat you gave out there. We're learning much from Pupa about giving back to our alma mater. Tito, will you be able to say something about Dennis? I believe he's not around to give a talk. Maybe you can say something about Dennis.
Thank you very much, Vic. Yeah, actually, Dennis said he won't be able to join us this time, but he sent a message of 2 sentences, and I will read it now. Dennis says, I wish to encourage alumni and friends to support this high-performance computing facility and thank UP RDFI for organizing and mobilizing global support for this project. Thank you very much, Dennis, for your brief but meaningful message.
Thank you very much, Tito. That's very nice to hear from Dennis. Al, fortunately, is here, and Mr. Al David may be able to say something and just to let us know what made him just out of the blue provide some help to UP, the College of Engineering. Al, are you there?
Yeah, I'm right here.
Would you like to be able to say something? Would you be able to say something?
I really don't have much to say. I have a very minuscule idea of what I should be talking to all of you. Perhaps we should skip this and put it in a written form. So anyway, excuse me for not being able to comment on UP Engineering Research and Development Foundation. All I want to do is contribute to your efforts to improve the funding. If it's necessary, we'll have Vic Villagracia sell some of my shares for my stock fund. Is that okay with you, Vic?
That's perfectly okay. Thank you very much, Al.
Okay.
Thank you very much for your talk.
All right.
That's easy enough, yes.
Yeah.
Okay. Well, in the Philippines, we have 2 wonderful donors, Mr. Frondoso and Dr. Reyes. Mr. Frondoso, would you be able to say something about your commitment to and why you made the decision to contribute to the College of Engineering?
Vic, I think Lito cannot join us today.
Okay.
But he sends his best wishes to the foundation, and we know Lito, our former chairman, is all support for all of our thrusts. So he wishes the foundation and the HPC project well. That's on behalf of our former chairman, Lito Frondoso.
Wonderful. Thank you very much for that, Ferds. Let's hear from Dr. Noni Reyes. If he could, Dr. Reyes, we'd love to hear from you, and so we can be inspired also to give more to UP.
Thank you very much. Good morning. Can you hear me?
Yes,
We
sir.
hear you perfectly, sir.
Perfectly.
Well, what I have to say is probably sort of a word of caution, something along the lines of the saying that you can bring the horse to the water, but making the horse drink is something else. This is based on my experience with the first mainframe computer that the university had That was the IBM 360. The thing was, what it was supposed to be, of course, primarily a educational and research facility. But what happened was that the university accounting system was, what shall I say, included among the assignments of the system. And it got to be a very overriding influence. I have to admit, I was one of the heavy users of the 360, but the problem was there were probably only a handful of users in the university. I think this may no longer be the experience nowadays because we are now, unlike before, all familiar with all kinds of stored program computing systems. But I understand the high performance computer really is a very fast machine. So by definition, it can take on a lot of users. I think one of the things we could do is to encourage the faculty to let the students make use of the facility by way of introducing them to what is available, and hopefully in the later years of their education, they will come to be also users of the machine. So that's what I'd like to say. Thank you.
Thank you very much, Doc Reyes. Those are all wonderful chat, and so glad to hear from Polly, from Dennis, from Al, and through Purge, Mr. Frondoso, and also directly from Dr. Reyes. With that, I'd like to be able to return the baton over to Dante, so he can ease into the HPC itself.
Thank you, Vic, and many thanks to our second round of donors. Dr. Noni, you will be very happy to know that your word of caution is much appreciated, and to make sure that we are able to take advantage of the horse being brought to the water, right? We have 3 excellent scientists in our mold to show that we have enough possibilities to carry out and use this facility. And we'd like to start with Dr. Ariel Blanco. Dr. Blanco is a professor of Geodetic engineering, has a Bachelor of Science degree from UP, Master of Applied Science in GIS from Melbourne, and a Doctor of Engineering degree from the Tokyo Institute of Technology. Very young scientist. Currently serves as the Deputy Director of the National Engineering Center, and he has successfully led R&D programs and projects, including the DOST-funded Field LiDAR 2 program on the nationwide detailed resources assessment using LiDAR, among others. Dr. Ariel will talk about how HPC can help our students and scientists conduct relevant research on how the country can make optimal use of our land and aquatic resources for industrial and agricultural use. Let us all welcome Dr. Blanco.
Good morning, everyone. I prepared actually a video. Yeah, now it's being shown. Good day, everyone. So I'm here to present about high performance computing for geospatial information and decisions. My name is Ariel Blanco from the Department of Geodetic Engineering, University of the Philippines College of Engineering. So I will discuss these 3 projects completed, ongoing, and upcoming, so namely GUHIT, Mappable, and Lungsod. So the first one is the geospatial assessment and modeling of urban heat islands in Philippine cities. Here we see a depiction of a urban heat island showing that the city center as well as other areas which are heavily built up are of higher temperature compared to surrounding areas which are rural, suburban, residential, farmland, parks, etc. So this project is funded by the PSHERD, the USC PSHERD, and was implemented from January 16, 2019 to August 15, 2020 at 7 cities as illustrated in the map to your right. So this project has these 7 components to develop the geodatabases of satellite imagery as well as the derivative products such as land surface temperature, characterize the evolution of urban heat islands through these images, to these land surface temperatures. Primarily, we are looking at surface urban heat islands, and we would like to determine the relationship of this LSTUHI with potential impacts to, say, water consumption, health, dengue, and even the energy consumption and other potential impacts related to, say, air quality. So we would like also to know at the different cities or even throughout the Philippines, how this land surface temperature varies and how they are impacted or controlled by certain parameters such as land cover. And we would like to simulate not just, say, daily changes, but within the day changes of this air temperature. So in this project, we also developed geovisualization and geospatial tools, as well as IEC materials, and we conducted several trainings. So this is an example of the daytime Landsat temperature surface or layer derived from Landsat 8 with a resolution of around 30 meters, showing areas in Quezon City which are relatively much hotter compared to other areas. Here we see the La Mesa watershed. Here we see the University of the Philippine campus and nearby areas which are treed compared to areas which are heavily built up, including in other cities as well, including Manila. So the pattern will change if we use a system or an image taken at night, where most surfaces have cooled, some other surfaces are still visible to be much hotter compared to others, including water because of the higher thermal capacity, and their inertia is quite low. So you have also visible here roads and other elements which are considerably much hotter compared to their surroundings, which have already cooled down. So under this project, we are also utilizing what we call upsampling or downscaling our products to higher resolution. Here we have a portion of the UP Diliman campus with 100 meters spatial resolution, with 30 meters spatial resolution, and our product, which is at 10 meters spatial resolution, showing clearly how hot or how cold other surfaces or its surfaces are within the UP Diliman campus and nearby areas. But more than the surface or land surface temperature, we're also interested in the air temperature, how it heats up through the day. And in this case, we will be able to identify areas which are considerably hotter. So this is what we call the, say, air-based urban heat island. So we did this for NCR, for Davao City, for Zamboanga, and also some simulation were conducted in Caraga region. So this is made possible with the use of the ASTI score system. And the model we use is what we call the weather research forecasting model, or the WERF model, and air temperature model here or shown here is at the level of 2 meters for these different cities. So in the project, we also dealt with microclimate simulation using what we call what is called the Envimet. So you can model a particular part of a city or even larger than it, and model the 3D character, the distribution of trees, the bare areas or the soil, and also the materials that make up the structures, the buildings. So here we see the cooling effect of Iloilo River and trees for the different times of the day in the particular date. So with this type of microclimate simulation, we are able to show the importance of water bodies as well as trees, and also to explore other ways of mitigating urban heat islands or lowering the air temperature. So the second project is part of the IM for Manila Bay, which stands for Integrated Mapping, Monitoring, Modeling, and Management System for Manila Bay and linked environments. So Manila Bay is quite huge, and together with its watershed, this is 28 times the size of NCR, and composed of several provinces, mostly from Central Luzon and Southern Luzon, plus the whole of NCR. So in this program, we have the project called Mappable. So this program and the component projects is funded by the Department of Science and Technology and implemented by the University of the Philippines, Diliman. So Mappable is development of integrated mapping, monitoring, analytical network system for Manila Bay and linked environments. So we are utilizing heavily a lot of images. As we can see here, optical images such as Landsat and Sentinel will show us different colors in Manila Bay, showing high turbidity or high total suspended solids, as well as areas having high levels of chlorophyll A, or level of primary productivity. You can see here the challenges based or posed by the clouds, but we do a lot of cleaning and masking as well as normalization of these data products. So the Laguna Lake is also part of this watershed system. So it will be included as well as the water quality in the different river systems within the Manila Bay watershed. So the project is not limited to just chlorophyll A or just turbidity or suspended particulate matter. We're extending it to microalgal classes, to developing an algal bloom index, to estimating coliform from temperature models, as well as detecting oil spills or oil slicks and marine debris, including garbage and plastic, and also going to the land. So we are monitoring the land cover changes, mapping the vegetation hotspots, going into the different levels of urban classification, as well as land degradation. So here are examples of the data that we have generated from Sentinel-3. So these are images taken by the Sentinel system operated by the European Space Agency in the European Union. So only the lower part is animated, which shows the chlorophyll and the patterns. You can see here, you have dark green showing high amounts of chlorophyll compared to others, and this correlates well usually with the turbidity that we see or the total suspended matter that we also see in this part of the bay. So those images are of a period of say several days, 3 days, 5 days, and it will be subjected to cloud cover as well, limitation. But we can also use satellite images taken by a geostationary satellite, for example, Himawari 8, which provides us data every 10 minutes. And through modeling between the models derived or the results derived from Sentinel and other products, we can actually estimate also, for example, the amount or the relative amounts of suspended particulate matter in Manila Bay, utilizing this near real-time approach. The last one is Lungsod, which is for the smart cities. Here we are looking at how smart cities can be even more successful. So we consider the multidisciplinarity, consideration of the multi-stakeholder, as well as creation of digital twin and the strong societal comprehension, awareness, and connection. So this project will be led by Dr. Jack Sarmiento. So LUNSOD means a linked up of geomatics and social science research for the development of smarter cities. So this will be conducted or implemented in Iloilo City, and we are aiming to create what we call a digital twin to enable simulation, to enable information sharing, and other things that will help in the better management of the city. And here is an overview of the system. And as Dr. Jack mentions it or says it, a smart government geospatial planning and management system to navigate the new normal. So that is Project LUNSOD. So with HPC, we can do better and help more people. Padayon at marami pong salamat.
Wow. Thank you very much, Dr. Ariel.
Thank you po. Thank you.
To the donors, I hope that got you excited. You know for sure that your donation will be put to good use. But that's just one of the very many things that we can do. In fact, our next speaker will tell us how the Department of Computer Science of the College of Engineering can use HPC. Let me introduce to you Dr. Vena Pearl A. Bongolan. Dr. Pearl is an associate professor of the department. She finished her PhD in applied mathematics from the Illinois Institute of Technology in 2005, Master of Science in Mathematics in 1987, and BS Applied Mathematics from UP Los Baños. We are very happy to have a mathematician in our fold today. Some of their current researchers are on the integration of cellular automata model and so on and so forth. So let's welcome Dr. Pearl talk about how the HPC facility can enhance the research capability of our students and faculty members at the Computer Science Department. Dr. Pearl?
Salamat po. I need to share my screen po. We have to stop sharing. Ayan. Thank you. Magandang umaga po sa inyong lahat. And so we will just start the slideshow. Yes. I could not help but play with the date. No, it's 10, 10, 10 times 2. You mentioned being, thank you sa natatawa. Salamat po.
There's mathematician there.
The first I'm happy to present is actually from my colleague Pros Naval. This is an awarded project of fish eye technology. So users with minimal knowledge of fish can obtain highly accurate fish population density, census, biomass, and species identification. So somehow Pros can, just by looking now, can identify fish or fishes and estimate other things, including how healthy our biomes are. And requires HPC infrastructure to train neural networks via deep learning. So this is the first of process 2 projects that will be presented here. So this is an awarded project, Fish Eye. And then I think this is still a proposal, deep learning-based accident video captioning using real-world surveillance videos. No? So it's a joint detection and captioning of a real-world accident surveillance video acquired from LGUs, and will use deep network architecture with metrics based on neural machine translation. This is sounding like a big brother to me, but they say it is for accidents. Well, I guess I would like to know, I would like people to know if there's an accident, and hope they respond quickly. What's going on? Why can't I move my slides? Sandali lang po. Okay. I don't know why I can't move that. Now, this third is from my former lab mate, actually, Dr. Valdez, Intelligent Transportation Systems for Building Smart Cities. Adrian Valdez has been working with Sean Palmiano and Dr. Sigua for some time on traffic. Now, they want to do an intelligent transportation system, use communications and new technology to increase road throughput and optimize traffic control for increased safety. And this would enable people to find services and information which they need to drive more safely and comfortably. So I guess we will all be connected. And yeah, this is from Adrian Valdez. Supposed to improve the quality of our urban life. Again, like we'll be being watched. And then the fourth will be big data analytics for personalized medicine. This is from a very young PhD, very young colleague, Justin Villar. And this is work done with PGC, now the Philippine Genome Center. And we're supposed to gain insights to help improve global human health. And well, here, the current, I guess the current paradigm, medicine of the present is one treatment fits all. The medicine of the future is more personalized medicine. Well, actually, what that means is that the medicines, that the drugs they will be giving us is actually formulated using our DNA. So it should fit us and get to the bottom of the problem quicker. So within drug discovery research and development, applications for big data range from design of clinical studies to understanding how to target molecular mechanisms to modulate disease processes. So this is from Justin Villar, a young colleague, and the PGC. Again, I am stuck. All right, and last but not the least, this is mine. Discrete continuous model for landslide-induced tsunamigenesis. The graduate student, Jose Marie Minosa, he just defended his proposal last mid-year term, and Eugene Herrera is the head of the panel. And the model runs using the HPC cluster of DOST ASTI compute co-air services, utilizes 80 cores, 256 gigabyte RAM for parallel computing. And I thought I will just show you his movie and just explain things here. This is the image on the left is a cellular automata model of the submarine mass failure or the underwater landslide that's going on. And it is modeled using a cellular automata or a discrete model. And this bigger image here is the tsunami being generated, and it is solved using a classic CFD Navier-Stokes equations. Now, and they are two models that are coupled somehow, and it is this tsunami that uses the ASTI resources actually. And yeah, we need high computing power. He complains now that each run needs 2-3 days, and we're trying to speed it up actually, even on the ASTI on the co-air. So it's well, his thesis is coming along. We were hoping he would graduate this sem, but probably not. But it's okay. Now the area is interesting. This is called the Northwest Borneo Trough. It is an area underwater just southwest of Palawan. That's Balabac Island, and this is Borneo. And well, what's coming out is depending on the assumed velocity of the sliding mass. And here, the deposits are 12 kilometers thick, and that is why Dr. Winspear, his co-advisor, chose this area. He is the geologist, no? And depending on the assumed velocity, you could actually almost wipe out the southern tip of Palawan by the tsunami being generated. And so this is a discrete model, and this is a continuous model. Yeah, this area, so the deposits here, well, come from natural sedimentation, including here at the mouth, which is from the Baram River, which is the boundary of between Malaysia and Brunei. So this area has been studied. We are concentrating on this area here. And we will blow up the landslide. So since that was hard to see, the landslide goes northwest. Yeah, it's running. And show where the last mass movement is. That's the landslide. And that's it. That's the end of my talk. Thank you very much. Maraming salamat po.
Thank you very much, Dr. Pearl Bongolan. Indeed, worthwhile projects that can benefit from the HPC. The next person I will introduce is from the DOST, currently the director of the Advanced Science and Technology Institute. Engineer Peter Antonio B. Banzon has received his master's degree in electrical engineering from the UP College of Engineering and also obtained his bachelor's degree in electrical engineering from UP. Let us all welcome Engineer Peter.
Hello, good morning, everyone. Thank you for coming on weekend. If I can just share my screen. Okay. Okay, can everyone see the presentation?
Yes, yes, sir.
Okay, thank you.
Peter.
Yeah, so good morning again, everyone. So as mentioned earlier, I represent the Advanced Science and Technology Institute. This is a research agency under the Department of Science and Technology. Our office is actually within the UP Diliman campus. We're right across the street from the College of Mathematics. So this morning I'll be presenting what our high performance computing initiatives are, specifically the core project that other speakers have briefly mentioned. Well, before I start, I'd just like to commend the college for their initiative to procure their own high-performance computing facility. We fully support this endeavor. We believe it will complement our own resources. And as mentioned earlier, it will lead to higher quality and higher quantity of research. Okay. 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 Can you see slide 2?
Yes.
Yes.
Okay. I just thought I'd like to start with a little history, a little background. Those of us who are of a certain age will probably recognize the computer on the left. This is a Cray 1 supercomputer, what is generally considered the first modern supercomputer. This was sold in the market in 1975, and it had a humongous numerical rating of 160 million floating point operations per second. So this was designed by the legendary Seymour Cray. And if you could see all the blue wires at the back in the middle, each wire there is precision cut considering the speed of light so that signals arrive at the same time and the processors do not have to wait for late signals. When these machines were being made, they actually had to hire a lot of small persons who will fit into this space to connect all of these wires. Okay, fast forward to today. The top dog right now in high performance computing in the world is the Fugaku supercomputer facility. This is located in Kobe, Japan. Fugaku is an alternative name for Mount Fuji. It's being hosted by Riken, and this facility is shared. This is a tier 1 facility. It's being shared all across Japan to the whole of the research community. So its peak rate, its current rating is 415 petaflops. So 1 petaflop is 1,000 teraflops. 1 teraflop is 1,000 gigaflops, and 1 gigaflop is 1,000 megaflops. So you can see, I try to divide those two numbers and my calculator couldn't handle the numbers. Well, just to put also in context, if you have a modern day flagship cellular phone like a Samsung Galaxy S20, the processor in that cell phone is roughly equivalent to a Cray 1 supercomputer right now. Okay, so I mentioned that the Fugaku supercomputer's current rating is 415 petaflops. This computer was actually scheduled for commissioning next year. But because of what's happening in the world right now, they had to rush it into service and at about half the capacity. And so it's doing a lot of COVID research right now, doing simulations of how airflow affects the spread of the virus, and of course, a lot of genomic analysis to find a vaccine. Okay. So in the United States alone, for instance, if you look at the current state of the high performance community there are almost 800 unique sites from west to east. Okay, not included in this picture, there's one site in Hawaii, at the University of Hawaii. If you look carefully, sorry, the different colors are represent academic locations or government or commercial facilities. So if you look at the San Francisco Bay Area alone, there are more than 100 high-performance computing sites. And literally some of them are across the street from each other. Amazingly, if you go to Alaska, Northwest, there is no HPC site there, which I find strange because it would be an ideal location because you would save a lot of money on cooling. Okay, so this is the current top of the top 500. So there's an organization that regularly ranks the top 500 supercomputing facilities in the world. So as this is the latest ranking, the top 5. So as mentioned earlier, the current number 1 is Fugaku. This is in Japan, and its rated capacity is about 415 petaflops. Each of the computers in this list was, during its time, number 1 on this list. So we see that current number 2 and number 3 are in the United States, operated by the Department of Energy. Number 4 and number 5 are in China. So all of them, except for number 5, use RISC processors or reduced instruction set architectures. Only the number 5 uses a commercial Intel x86 platform, which is the most popular right now. Number 4 uses a custom chip from China that is curiously very similar to a Western design. Okay, so we can see that the pace of growth of these computers is increasing, and we are actually targeting the first exaflop machine next year. So it looks like Fugaku will be the first because they will roughly double the capacity by next year. Also, the United States is looking at around 2 or 3 systems in the exaflop region next year. So again, one exaflop is 1,000 petaflops. And these numbers are so huge that just to put it into perspective, one second, for instance, is 10 followed by 18 zeros. So which is why October 18 is usually called exaflop day. So if you go back in time 1 exaseconds, that would be more than twice the age of the universe. So that's how large these numbers are. Okay, so what do we have in ASTI? Our HPC facilities, we call it core because we look at it as being at the center of a lot of things, of a lot of research. It's a research infrastructure that we provide and share to the research community in the Philippines, all across the country, and it's currently free of charge. So this is what it looks like inside. It's a very far cry from people in the top 500, though someday we do dream of being in the top 500. Okay, so the core project has 3 main services. The flagship service is our high-performance computing facility. We also provide data archiving because anytime you have high-performance computing needs, you also have high data needs. So that data has to be stored and protected because that's the most valuable thing that you get from the facility. We also have a science cloud. This provides a lot of virtual machine hostings for researchers who do not require a high-performance computing facility. So right now, a lot of the servers that, for instance, are being used by the IATF for COVID tracing or COVID analysis are being hosted in our facility. Okay, so I'll be focusing more on the high-performance computing service. So as mentioned earlier, the basic idea behind the high-performance computing setup is you have a large task with large amounts of data, and you split it into smaller bite-sized chunks that are spread across hundreds or even thousands of smaller computers, and then they all work on the same problem simultaneously and generate data that you can later consolidate. And depending on the nature of the data, you also need a visualization facility so that you can look at the results of your simulation or your analysis. Okay, so our current capacity is, we just upgraded some of our resources. We have a 3,400 core machine for compute, for general purpose computing, and for specialized graphical performance units, we have a 20,000 core machine. So the combined capacity of that is about 130 teraflops, which again, if we compare it to a Cray 1, which was the standard before, that's about a million Cray 1 machines.
Wow.
In terms of storage and memory, well, even though if it's that big, it's still not the biggest one in the Philippines that we know of. So for storage and memory, we have 956 terabytes of hard disk, magnetic disk storage, and 25 terabytes of random access memory. The machines are interconnected together via a 10 gigabit Ethernet connection. It's not the fastest interconnect available right now, but it's adequate for our needs. Okay. The facility itself is divided into 3 locations, so 3 physical locations, primarily because of space constraints. Our building is not that big. So we divided the HPC setup into 2 sites, one here in UP Diliman and another one in a data center in Makati. And we also have another site in the ICT. So this is both for because of space constraints and also to provide redundancy in case of a disaster or power failure in our building. So having a site in a major data center in Makati also allows us to provide faster access to the services to people from remote locations, for instance, in Cebu or in Davao. Okay, so what are some of our main research applications? Some of them have already been highlighted. So these are currently our main classes of research problems that we support. So bioinformatics is traditionally one of the biggest ones. One of our biggest users is actually the International Rice and Research Rice Research Institute in Los Baños. Of course, weather forecasting and climate research is also a traditional need. We provide the service to the NOAA project, as well as to our weather bureau, PAGASA. Chemistry, molecular modeling is there. CFD, of course, is always here. And the biggest growing research application area that we are seeing right now is in AI and big data analytics. These are just some of examples of the research applications that we have supported. Weather forecasting, for example, we want to determine the interactions between mountain ranges and cyclones. So may affect yung geography of a landscape to severe weather conditions. Assistance in CFD for post-earthquake surveys. I'll just go over this quickly. Of course, AI, we do a lot of projects on AI and bioinformatics. For instance, we have a group analyzing the genome data of negritos to try to understand more how these groups spread, to understand more of our history and anthropology. We also provide computational material science support, not just to the local community, but sometimes to the international scientific community as well. So this one, for example, is looking at molecular modeling for cancer research. Okay, one of the other main services that I mentioned earlier, aside from HPC, is our data archiving service. So we do host a lot of data sets that we make available to researchers for them to analyze. Our data catalog currently has 255 terabytes of storage. These are some examples of the data sets that we have. These are private data sets that we make available on request, primarily various satellite imagery from the satellite subscriptions that we have. These are high-resolution, multispectral images. We also have public data sets that are made available to the general public, and they can readily download this data. For instance, we have the 3KRG. These are the genomic data for 3,000 varieties of rice. So this is owned by ERI, but they make this available for sharing to the public. We also have landslide hazard maps and storm surge hazard maps. We have short-term weather predictions. So right now we can do 12-kilometer resolution. So imagine a grid where the size of the squares are 12 kilometers. So it's not ideal because that's still a fairly large area, but we are working to increase the resolution for these weather forecast products. Okay, so these are some pie chart of the users, where they are coming from. So almost half are from UP Diliman, actually. And we also have users from other universities, UP Los Baños, of course, San Carlos in Cebu, Ateneo, and some government agencies. Okay, so the services of CORE are made available to a diverse range of users. These are the main people that we have right now: meteorologists, researchers, weather forecaster scientists, and general students. Okay, these are some research publications that we have accumulated. When you access CORE, or when we give you access, we request you to acknowledge the assistance of the project, and also we request for a copy of whatever publication you have made. So this one, for instance, was published in Nature, which is a very prestigious scientific journal. It's about the genomic variation in 3,000 varieties of rice. So this is important in the long term. Apparently, there are more than 100,000 varieties of rice. Because the global supply is not keeping up with the global demand. So we need to find varieties of rice that are very productive or that will grow in non-traditional conditions. Okay. This is an example of a research from someone in the School of Statistics. So it's about person fit analysis. This is a paper from the Department of Computer Science on handwritten digit recognition using AI. This is a paper on flood modeling from the UP Open University. This is someone from the UP EEE Institute working on fraud detection for vehicular sharing companies. This is someone from the Polytechnic University of the Philippines, so another state university. So her research is on temperature variation in Ifugao. So we do support a wide variety and very diverse range of users. How do you apply for access? So it's very straightforward. You submit a request through an online form. And if your organization already has a formal collaboration with us, then we short circuit the procedure and go to the next step. Otherwise, we will request for an endorsement letter from your advisor or your supervisor. Then we ask for some details as well as a description of what you intend to do on the facility, your service requirements, and then we give you a copy of our policy documents. Okay. So when we receive the complete set of applications, then this is evaluated. And when it passes, we create an account for you and we send you your credentials, basically your account name and password. So when you do encounter a service, when you have a problem, you log into this user portal on the screen to submit your service request. So when you log in there, you will see the screen where you can generate a ticket so that we can track all outstanding requests. So please do not email us, but we request you to go through this system. Okay, this is our use policy. It's fairly liberal. There are just two general limitations that we have. First is you do not use the facility for illegal purposes. And second, you don't use it for commercial purposes. Okay, so these are some useful links. You can go to this URL for more information about the project, and that's our email address. We are also on Facebook, Twitter, and YouTube, where we do have tutorials on how to access the facility. Okay, thank you very much for your time.
Wow, Engineer Peter, thank you very much. And again, thank you very much, Dr. Ariel Blanco, Dr. Pearl Bongolan, and Engineer Peter Banson for showing to us the projects that could be supported by high-performance computing. And to the donors out there, 20, 10, 10, 20 means something different and relevant to us. We have generated 10 million already. We need 10 million more so that we can put together the 20 million to completely fund this project. So please bear that in mind. We need your 10 million. At this point,
in 2020.
Within 2020, that's correct, within 2020. Thank you, Boss Tito. At this point, we would like to entertain questions from our participants, and the Q&A discussion will be led by our very own engineer, Rafael Nestor Chicho Mantaring, an electrical engineering graduate of the college in 1978, a former senior executive of IMI Electronics, and was at some point the chairman of the electrical engineering department of UP. Boss Chicho, the floor is yours.
Thank you very much, Dante. I guess Dante wanted to take a break, no? from this session. Okay, there are a lot of questions that have started to pour in. I'd like to remind people that if they have any questions, please use the question and answer chat box to post your questions, and I will gladly forward these questions in this webinar. Maybe starting off with Peter, since this is the freshest presentation. No? Does the two questions? No, does ASTI charge for using the core facility? Number one, and number two, will it be possible to combine ASTI's core with the HPC facility, for example, that the College of Engineering is planning to set up to make the entire system more powerful?
Yeah, yes. Thank you, Chicho, for that question. So, yeah, Chicho was my professor in computer architecture. So, yeah. The first question is, are the services free of charge? Yes, so far, as long as it's for public good, the research objectives are for public good. The facility is currently funded by the national government. So our expenses are covered. Even with the budget cuts, we can operate so far until we get until this funding is assured from the Department of Budget. So having researches being performed at the facility actually strengthens our position with regards to requesting and assuring the availability of government funds. The second question is, will the UP College facility be somehow interoperate with our facility? And the answer is, again, yes. We can connect the two together so that they will work together on projects that will require increased capacity. So this is a model that is being used by a lot of supercomputing centers around the world, especially regional. There's actually a group in ASEAN that's working to establishing an ASEAN-wide shared HPC facility. This is planned to be located in Singapore, and this will be made available to the entire research community in ASEAN. So this is going to be a petaflop class facility. So people in the Philippines will be able to access it through our facility.
Oh, thank you very much, Peter, for that answer. That's exciting what you just said. No? By the way, this is just my curiosity. What is the most powerful facility right now in the Philippines? Would you know?
Okay. Our facility right now is probably in the top 5. We know of a more powerful cluster at the Asian Institute of Management.
Okay.
This is a donation from Acer. So their facility is used for AI and big data analytics, where they have a master's, a graduate program in big data, I think. So this is about twice the computational power that we have. So the business people have more than double the computational power of engineers. There's also a big cluster in Pag-asa, or Weather Bureau, because of the large scale of numerical predictions that they have to generate in a timely manner. But that's a production facility. So if they need to experiment on different algorithms or weather models, they use it they run those on our facility. There's another large facility at the Philippine Genome Center, but that's dedicated for genomic research.
Okay, thank you very much, Peter, for your answers. No? There are a couple of questions related to COVID. No? So I'll address the first to Dr. Ariel. No? Has there been any attempt in your geospatial analysis, for example, to incorporate the incidence of COVID?
As part of the endeavor supported by RP, we actually developed the mobile app, but it was hindered somehow by the policy of the government to use only one, contact tracing application. So what we did is basically we turned it into something like a community linking or community connections application with still some inkling towards epidemiology. But in terms of looking at the different, say, incidences, so we defer that to the UPRI and so on, but we focus more on the data collection part.
Thank you very much. There was a similar question for Dr. Pearl. No, someone is asking whether there are projects of the Department of Computer Science which deal with COVID, you know, maybe in the same light as geospatial analysis.
Yes. Yes, thank you. Well, I have not stopped working on COVID. No? So since the lockdown, and the alumni engineers supported that effort with my graduate students and former students. And up to now, we're working on it. I have undergrads working on it. That does not really use HPC. Somehow the modeling for it does not use HPC yet. It's actually, well, my collaborators at the Center for Informatics in San Agustin, Iloilo, baka sila yung magbe-big data. I do not know, they have not asked me for help concerning computing facilities, no? But they might be the ones using, who will have use for HPC, but they have not told me yet. But right now, the modeling we do does not need HPC yet. But the informatics that they do, they might.
Okay. Thank you very much,
Thank you.
Pearl, for your answer. Okay, another question. This is again directed to Dr. Blanco. No, let me see if I get. Yeah. What is the status of because it was indicated in your slides that GUHIT is a completed project,
Yeah.
but it seems to be something that that should be done continuously by government. Also, what is currently the status of GUHIT?
GUHIT is basically the products. For example, the outputs will be utilized by the Department of Human Settlements and Urban Development as part of the CIDRA evaluations or assessments. So we have been talking with them on capacity building, and the department has also a project with the Training Center for Applied Geodesy and Photogrammetry. It's called LUCIS, or the Land Use Zonation Information System. So the results of GUHIT will be incorporated also in that system. And in the upcoming project on Smart City, we will be also incorporating some of the methodologies, the models in Iloilo. For example, to provide additional input layers or continuous simulation for air quality, or even wind, and even, of course, the air and surface temperature. And this can complement the, for example, mobile app that will be used by citizens in reporting whatever their concerns are, whether it be in traffic or health or crime or feeling of safety and so on. But our plan actually in the laboratory, I'm heading the laboratory and research. We would like to maintain our own, say, system, no? Because, for example, it happens that once we complete a project, sometimes the recipient or the beneficiary agency is not yet ready to take on the system that was developed. So that was the case, for example, with the LLDA. So we have to, for the meantime, support them continuously, and then until such time that they are able to fully utilize and operationalize the system that was developed by the project.
Thank you very much. No, I suppose that question also applies to your other project, Lungsod, no? Because once it's completed,
Lungsod will be starting in January, I think.
Yeah, once it's completed, you hope that somebody picks it up and takes it over.
The Iloilo city government.
Okay. Yeah. A question for Dr. Pearl. No. Are there because it seems that your submerged landslide project is quite interesting, no?
Oh, thank you.
What was the motivation for doing that? Or is it supposed to be for early warning, early detection, or?
Actually, I served on the steering group for natural hazards and disaster risk of ICSU-ROAP, the International Science Council Regional Office for Data for Asia and the Pacific. I served there for 2.5 years. And my colleagues there are, many are geologists. And they brought this question up as soon as I joined that steering group, no, and they said, "Pearl, are you aware that you have 12-kilometer deposits off the coast of Palawan?" And so it was during my tenure that we started talking about this, and I said, I can model this, except that at that point, that when they asked me, I was still working on landslides with another graduate student. Lee Haveliana graduated 2018. So I started serving on ICSU-ROAP 2016. I said, yeah, my landslide guy is still graduating, but we will get to this problem. And well, finally, the landslide guy graduated and stopped talking to me. I guess he got busy. He got promoted at UP Baguio. And then another student, so Joma Minos, took it up. And so now he's the one merging the two approaches. So cellular automata landslide via an ultra-discretization of the model equations, and then the classic CFD for the tsunami. And you see, that area is being watched by several geologists. It is still largely theoretical. We have not found evidence that some big tsunami has happened, but several geologists are investigating it. No, so they seem to be worried about that Northwest Borneo trough. We have tried, nagtanong na ako sa Palawan State if we were looking for carbonate deposits. I said, have you seen these kinds of rocks on the west coast of Palawan? Wala pa naman nakikita, no? So, but, well, we'll continue to investigate that and tell you if the island of Balabac could get inundated, if there's a big chance that it will get inundated, kasi nga depende rin sa assumed velocity ng sliding mass, which nobody knows about. So it's largely theoretical, So don't worry yet.
Oh, okay.
I say, don't worry.
Thank
Di pa
you.
ako sigurado.
Thank you, Dr. Pearl.
Thank you.
This question isn't really addressed to the panelists, no, but I think it's a very interesting question, and I'd like Doc Happy to chime in. Will the UP system be amenable for research tie-ups with other SUCs that will require HPC in their potential researches? No, Doc Happy, if he actually typed in an answer, but I think this is of general interest.
Hi, Sir Chisha. Yes, actually, we are striving to do that. But first and foremost, we have to, of course, set up the infrastructure for now. As Sir Peter mentioned nga kanina, yung usage already ng UP for the cluster, for their core cluster is already, I think, nasa 40+% na eh. So it's high, kaya nga we're setting this up as a complementary capacity po natin. And in time, once we hopefully get all of the capacity that we need, we really want to consider expanding this for SEC collaborations. Even there were people who actually asked about commercial use policies. That's still something that we want to consider. Kasi, for example, in cases where, let's say, the companies can do, let's say, collaborative research with academe, we can explore that. For the SECs naman po, for collaborative research as well, I think that's perfectly fine as well. Yung nagtanong actually was my thesis advisee under ERDT nga eh. So it's a good question.
Okay, that's very good to hear, Happy. No, I think we have time for one more question. No? So I'm going to address this to Peter. No? Are there plans, for example, for the government to pump in more money so that the core facility will be further expanded?
Well, right now, that is our dream to be a sort of a national high-performance computing facility, similar to what other countries have, especially in our region. But I think at this time, it's not a very compelling proposition to the government to fund expensive computers because of what's happening right now. But so far, they're funding continued operations, and we're happy with that. We just actually doubled our capacity. But of course, if we can tap others funding sources, that's also an option for us.
Yeah, I personally, I think you should advertise to the Philippines that you're actually very important to the IATF right now, no? housing all of the data of the IATF. Anyway, now there are still a few more questions. I guess some of these can be answered directly through the chat box, but we're running out of time. So at this point, I'd like to thank people for their questions and for their participation. And I'm going to turn you back over to Dante. Dante, take it away.
Thank you very much, Chicho. Thank you very much, our speakers and panelists. Very brilliant scientists. So now we know what kind of people will be supported by this project and what kind of people will become like them in the future if we offer this facility for our able scientists. So at this point, we go back to the foundation and ask our indefatigable executive director to give us an update on what is going on with the foundation. Engineer Tito Aliga, Boss Tito as I fondly call him, is a graduate of UP College of Engineering as well. He got his master's degree from the Wharton School of Business. And he will give us an update on what's going on with the foundation and our desire to generate more funds for the College of Engineering and for the HPC in particular. Boss Tito?
Thank you very much, Dante. So good morning, everybody in the Philippines, and of course, good evening to our US audience, as well as I saw some people logging in from Kuwait and the Middle East. In this part of the program, we wish to report the progress of our legacy initiatives, for instance, faculty development, student support, and special projects. First, we are in the finalization phase of the Philippine Energy Systems Modeling Project, which we commissioned to Dr. Mike Pedraza and his team of researchers from the Energy Engineering Program. Second, our Engineering Mechanics ES-101 textbook and workbook projects is in progress. This is authored being our member, Dr. Benny Pacheco of the Institute of Civil Engineering. Number three, while we have put on hold our monthly technology hour, we are reconfiguring our approach to help bring 5 R&D projects of UP Diliman and College of Engineering to full commercial impact. This effort is being led by our Innovation Committee Chairman, Chicho Mantaring. We are embarking on a project to digitize our backroom and front office systems in the foundation. And this is led by our Vice President, Dante, and the Audit and Governance Committee Chairman, Was Roquesa. Our strengthened investment strategy is being driven by our Finance Committee Chairman and Treasurer, Dean Ega Atanasio. In the meantime, we have new scholarship programs for the academic year 2020-21, while we are also contributing to the laptop drive of the college. So again, we thank our donors for these scholarships for continuing their support. Now, in terms of professorial chairs, the Dean's Office is completing the vetting of available professorial chairs and faculty awardees. There are about 280 faculty members, and from where we sit, there will be there's estimated to be at least 150 qualified professors to receive chairs and 33 who will receive teaching grants for this academic year. This 2020, 12 new chairs have been added. We have recognized donors earlier this year, and the last two, Gus Lagman and Danny Reyes, during our August 14 webinar. So for this time, we would like to acknowledge 4 donors. Just to introduce them, first one is Elazar Doji Simon, IE85, who is the author of 2 books on artificial intelligence and currently the Senior IT Director for Global Infrastructure for New York University. He set up the Elazar Lorenzana Simon Professorial Chair in Artificial Intelligence. The second one is our former Dean, Aura Matias, who set up the Dr. Maria Aura Teodora Castillo Matias Chair in Human Factors and Ergonomics. And through IE, she did not wait on her original plan to set up the chair when she retires in 2025. So we have it now. The third one is Engineer Rani Eason, CE89, who set up the Ronaldo S. Eason Professor Chair in Structural Engineering. He's the principal engineer of his own firm, R.S. Eason and Associates. He will not be able to join us today because of a client meeting, but I will read his message later on. And number 4, the Philippine Society for Soil Mechanics and Geotechnical Engineering, represented by its president, CE Professor Dr. Alexis Acacio, who sponsored the Dr. Salvador F. Reyes Chair in Geotechnical Engineering as their gift to Dr. Reyes on his birthday last September 11. So let me now ask our first chair donor, Doji, you have the floor.
Thank you, Tito. Just would like to say that I'm delighted to know that the University of the Philippines has invested in high performance computers. Just by that acquisition, UP distinguishes itself as a world-class research institution. Top universities here in the US, such as Harvard, Yale, MIT, and even NYU, have invested in HPCs, thereby attracting not just research grants, but also the brightest and the best minds that get to work on projects relating to, as mentioned by some of our speakers, genomics, weather, climate, environmental, forecasting, logistics and transportation, simulations, big data analytics, artificial intelligence, drug discovery and other research breakthroughs like COVID-19, cure for COVID-19 or various types of cancers. Such breakthroughs can be achieved in much shorter timeframes due to the massive computing power delivered by the HPCs. To inspire all of us to support UP's goals, in NYU alone, we have water-cooled CPUs equivalent to 20,000 cores that achieve 2 petaflops of computing speed. That is 10 to the 15 of floating point operations in 1 second. So congratulations to UP for this brilliant move. Secondly, I'm happy to be able to give back to my beloved alma mater through this professorial chair in artificial intelligence. AI will affect the lives of many people around the globe. It is important for the Philippines to carve its niche in this global movement. And this professorial chair is one of many steps in accomplishing that goal. Once again, many thanks to UP for this opportunity to not only give back, but more importantly, propel UP as a leader in AI in the Philippines and in the region. Maraming salamat po.
Thank you very much, Doji. And talking about artificial intelligence, I have come up with some ideas that we are now plunging into the world of Internet of Minds. And somebody said that's just programmed mental telepathy. But that's the future, I think. Our second speaker is our Is Dean, former Dean Dr. Aura Matias? Aura, there you are. You have the floor.
Good morning to everyone. I sincerely thank the Foundation for the opportunity to share a short message. The decision to give back to my alma mater by way of a professorial chair in human factors and ergonomics was honestly a knee-jerk reaction to a sudden turn point in my academic career. I intended to reapply for a professorial chair myself, but eventually came to a realization that this year was a golden opportunity for me to give back instead of receiving. The Department of Industrial Engineering and Operations Research will be celebrating its Golden Jubilee. I have been a faculty member of the Department of the Industrial Engineering Operations Research since 1982, fresh from graduation. That's 38 years and running. My academic career has been blessed despite the many challenges, the ups and downs, stress and disappointments. I will be candid in confessing that there were more than 3 times that I was almost tempted to leave UP and accept more lucrative job offers here and abroad. But thanks to my mother, former Dean of the UP College of Pharmacy, Amorita Castillo, who dedicated her entire career as an academic herself, was my role model, and I wanted to make her proud that I followed her footsteps. The love of my life, Rene Matias, Ataw Alpha, Brad, was also instrumental in my staying in UP. He made me choose between him in the Philippines over a job opportunity in the US. Obviously, I chose my heartthrob, with whom I spent 30 happy years with 3 children. This year also marks my 60th birth anniversary. So I wanted to do a good deed for the blessings that I have received. I had a happy marriage. My husband passed on in February of 2018. My sons earned their college degrees in UP and are doing well. My only daughter, who was born with Down syndrome, is now a beautiful lady and learning new skills slowly but surely. I have an intelligent granddaughter who makes me laugh when I am down. And my parents left us with a comfortable inheritance. Actually, I thought of retiring this year as I have become financially independent. Hence, the decision was no-brainer. The donation commitment was feasible. The PCA is intended to motivate our younger faculty members within the Human Factors and Ergonomics Lab to conduct research in this area. Our laboratory has mainly been instructional in nature. Human Factors and Ergonomics is more popularly known for branding furniture and computer accessories. And in industry, it's mainly on occupational health and safety assessments. Our laboratory have worked with some industrial design students at the College of Fine Arts, where we had the opportunity to see the marriage between engineering and the arts. Now, thanks to COVID-19, our laboratory found its niche serendipitously when UP faculty inventors sought our help in testing their inventions or innovations for usability and ergonomic assessment. My dream is to build the usability and ergonomic testing center in our department as a facility to perform product testing requiring human test subjects for research and development. Hopefully, with this professorial chair in human factors and ergonomics, it will provide the engine to conduct research activities towards this end. As a parting word, I wish to thank again the Foundation for the opportunity and the avenue to give back to the university that has made my life very comfortable. I am a competitive person. I wanted to be the first to donate, but Doji Simon beat me to it. So I call on other IE alumni, you know who you are, and my own batchmates to hit the call to support our college faculty and students. Magandang umaga po sa inyo lahat.
Thank you very much, Aura, for those inspiring words. The IE class of 1982 is a well-resourced group. It includes Dante Briones and Mon Hoxon. Okay. I will now turn the floor to Alexis. I will read Rani's after you, Alexis. So please, Alex. There he is.
Okay. Good morning, everyone, and good evening to those in abroad and the other places worldwide. The PSS MGE, or the Philippine Society of Soil Mechanics and Geotechnical Engineering, is a young society. Its objective is to enhance the practice of geotechnical engineering. And of course, Dr. Reyes is one of our top members also. And the decision to create a professorial chair for Dr. Reyes is practically was a very easy one. And this is mainly to honor Dr. Reyes for his contribution to UP, to the geotechnical profession, and he has always been an inspiration to each practicing geotechnical engineer, even structural engineer, and for any civil engineer for that matter. So we would also like to thank the UPERDFI and the UP for serving as a platform to convey this professorial chair. So Dr. Reyes, belated po ulit, pero happy 90th birthday. This is to commemorate the 90th birthday of Dr. Reyes. Maraming salamat po.
Thank you very much, Alexis. And now I would like to read the message of Rani Ison. He's busy meeting up with a foreign client, he said, so he emailed this message to me. And I read, good morning. I hope everyone is safe and well. I have been practicing as a structural engineer for the last 32 years and have been involved in the code and standards development in the country, particularly the National Structural Code of the Philippines. I have also been involved in several damage assessments after major earthquakes through the years. These experiences have brought me to realize that despite the advances in technology and multiple researches in building design and structural safety around the world, we still need to do our own researches to understand and properly adopt this information locally. Being a part-time faculty of the Institute of Civil Engineering as well, I would like to offer this professional chair to the Institute. I regret that I cannot come to this event due to a commitment, but I would like to thank UP RDFI for being a venue to enhance further our faculty, and I hope my contribution will help the foundation further reach its objectives. Very truly yours, Rani Ison. Thank you, Rani. I hope your meeting is going to be very fruitful. And then before I turn over the floor to Dante, we would like to ask again, Dr. Noni Reyes, being the lone chair honoree in this program. Doc Reyes, your message, please.
Yeah.
Yes, Doc, it's your floor. The floor is yours.
Oh,
yeah.
Want to hear a few more words?
Yeah, this is related to the professorial chair.
I think, well, I'm very impressed with the papers that were presented, and I'm very hopeful that, to me, what is most important is the usage of the facility, that it be as full as possible for research and education.
Okay. Thank you very much, Doc. And with that, I would like now to turn over the floor back to Dante.
Thank you very much, Boss Tito, and thank you very much, donors. We are about to end this session, and what better to hear than to hear from our president of the UP Alumni UP Alumni R&D Foundation, Mr. Ferds de la Cruz, a Tau Alpha, and a very proud one. Used to be the CEO of Manila Water. He claims that he is more of a sales and marketing man than an engineer. So please all welcome Ferds de la Cruz. Ferds.
Thank you, Dante. Morning to our viewers in Manila and the Middle East, and good evening to our viewers in the US. Thank you for joining episode 2 of our HPC webinar series. Congratulations to our presenters, Dr. Ariel Blanco, Dr. Pearl Bongolan, and Engineer Peter Banzon, for clearly making the case for a high-performance computing lab for the College of Engineering. We thank our donors for their huge support for our HPC project, our laptop drive, and for the new professorial chairs. Your contributions will go a long way in sustaining the R&D prowess of the college and in fast-tracking its digital transformation. As was already mentioned a few times by my colleagues this morning, October 10 or 10/10 is a timely date to recount the almost 10 million in donations and pledges we have achieved so far, and the slightly more than 10 million peso balance to reach our 20 million goal in 2020. We are getting there, but we still have some ways to go. The UP Engineering R&D Foundation knocks on your generous hearts to support UP Engineering's dream to establish its very own HPC lab so that it could help society faster and better. We look forward to seeing all of you in episode 3 when we inaugurate the COE HPC lab and launch our campaign to interconnect other HPC labs in the country and beyond to build a wonderful network of computer clusters. Mabuhay ang Universidad ng Pilipinas, mabuhay po ang UP Engineering. Maraming salamat po, and let's all keep safe. Back to you, Dante.
Thank you very much, Pangulong Ferds. So just a reminder to all our participants, your donations can come in other forms other than financial. Your time or your network is valuable for us as well. Let us know. You can be part of the UP Engineering R&D Foundation and work with like-minded people who are single-minded in making UP produce the best engineers in this country and the world. Lastly, we hope to see you next time and listen to how we plan to use our HPC facility as the core for interconnecting with ASTI and with other universities in the Philippines and the rest of the world. The intent is we are counting on you to support this project for the UP COE to produce the best engineers for the country and the whole world. Mabuhay kayong lahat. UP fight.
Yes, sir. Thank you, Dante.
Thank you, everyone.
Thank you, Dante. Thank you, everyone.
Thank you, everyone. Presenters and donors.
Salamat po.
Thank you, Ara. Yep. Yeah. These are the details of the donations. In the US, it's FUPA. Vic?
Yes.
Okay. So please take care of the our US donors.
Be happy to. Yes.
Yep. And I understand there is a 2020 time limit to make their donors generate more benefit for them.
That's right.